Hello everyone. In today's lesson, we are going to discuss all about data management, specifically the data. So here today we are going to start the second half of our semester. So now we're going to move forward and let's see what are those core idea about this data management, or specifically the data. We're going to deal with the data, or those terms that we can encounter while we are discussing data management. So I hope that you understand everything about this. And well, of course, since we are talking about data management, it will always deal with statistics. Statistical tools derive from mathematics that are useful in processing and managing numerical data to describe a phenomenon and predict values. So, why statistical tools are important? Statistics is one of the crucial parts of planning. So, without statistics, the plan can't be possible. Statistics helps to do planning in business, economics, and government level, and also in trade. We can anticipate all these aspects with the help of statistics. It also helps in determining the prices of various products. And importantly, statistical tools are very important for those researchers, or when you are going to conduct your study or the so-called thesis, and it can't be possible without statistical tools. Statistics is plays important in health industry as well. Why? Because it helps the doctor to take and manage the data of their patients. And also it may help the government to check out what education schedule can be beneficial for students. We are using as well statistics on that. And also, most important, the beneficial importance of statistical tools in education, that teachers can be considered to be supportive as researchers during their classrooms to recognize what education technique or strategy may work on which students and know the reason why. So that's how statistical tools very important. And we are going to discuss about the general fields of statistics. We only have two general fields of statistics. We have descriptive and inferential. So what is the descriptive statistics? If statistics in general basically deals with analysis of data, then descriptive statistics part of the general field is about describing data in symbolic forms and abbreviated fashion. So from the word itself, descriptive statistics describes data. So of course it is written in the Holy Book that the truth shall set us free. Therefore, we need to understand statistics that paves the way towards intellectual freedom. So supply this is singular information but armed with statistical inquisitiveness. And descriptive statistics can further describe the given information to the extent of its depth and breadth. Also, in descriptive statistics, the use of single measures to describe a set or distribution was introduced. So remember that when we say descriptive statistics, we are only describing data. And let's see now what is the so-called inferential statistics. Inferential statistics has the ability to infer, to conclude, or to generalize, and it offers the right tool to predict values that are not really known. So it is more depth than the descriptive. We could probably argue that descriptive statistics with its characteristic to describe is sufficient to depict any given information, right? So while it is effective to describe a manageable size of data, it can hardly engulf a sizable amount of data. So descriptive statistics isn't enough. So thus, we have the kind of situation wherein we have the inferential statistics, the alternative technique that we can use. Say we want to determine the estimated monthly earnings of all the workers in certain region. By attempting to apply descriptive statistics, it would be impossible to ask all the workers in the entire region about their monthly income will be known. But by using the inferential statistics, we would instead practically decide to select just a small number of workers, somewhat like you are picking or selecting people, not the total population, but you're going to get a sample from the region workers and ask them of their monthly income, and from there we can predict or approximate in a more or less fashion the monthly income of all workers in the entire region. So that's how inferential statistics work. It makes defining the data more easier, right? So on that example, we get the sample from the population and get those data instead of getting the elements or the information from all of the workers in the whole region. And now we're going to move forward to the measurement. How does it work? So it essentially means quantifying an observation according to a certain rule. That is the so-called measurement. So for instance, the presence of fever can be quantified by using thermometer. And then the body weight can be determined by using a weighing scale. Or also when we are measuring mental ability of a person, we can quantify it by using the written examination that can generate scores. So the quantification sometimes can be done by simply counting. Yeah, that's how when you are counting a lot of data or a lot of items, you're quantifying already, or you're getting the size by using tape measure, you're getting the size of your height, like that. You are already using the measurement. And then what are those types of quantitative information? We only have two, just like the fields. We have variable and constant. So variable is something that can be measured and observed to vary. So, and also in constant, this is something that does not vary and it only maintains a single value. Make sure you remember that variable can be measured and observed to vary. And constant, something that does not vary, it only maintains a single value. So in quantifying an observation, these two, the variable and constant, are the types of quantitative information. And scales of measurement. Here is the summary already of those four. We have nominal scale, ordinal scale, interval scale, and ratio scale. So in nominal scale, for you to always remember, it is also called the categorical data. In ordinal scale, this is like you're doing a rank, getting the position. So it's so-called the rank data. In interval, this is a measurement data, and ratio scale is under the interval scale. So to quantify an observation, it is necessary to identify its scale of measurement. It is known as the level of measurement. Okay, aside from the so-called scale of measurement, we can be also known as level of measurement. Scale of measurement is the gateway to the fascinating world of statistics. So without sufficient knowledge of it, all our statistical learnings lead to nowhere. So we need it's very important that you understand first what are those level of measurements. Now we are going to define first the nominal data. Nominal data, it concerns with categorical data. It simply means using numbers to label categories. This is done by counting the occurrence of frequency within categories. So one condition is that the categories must be independent or mutually exclusive to each other. So this implies that Once something is identified under a certain category, then that something cannot be reassigned at that same to another category. So let's see the example of that nominal data. Say we have this, an example for the nominal data. If we want to measure a group of people according to marital status, we can categorize marital status by simply assigning a number, for instance, 1 for the single and 2 for the married. So what are we talking about? Like, one condition, this condition, as we can see, is that the categories must be independent or mutually exclusive. Say, if you are one of those person that we are going to get data, you're being asked what is your marital status, then you're single, you should be included to the first column, and you're not, or you will never be included simultaneously to the next column, to the second column. You're single and then you're married, like that. And if that's the case, then we are going to create another column or another category, like a widow, like that. Okay. And let's move forward to the ordinal data. This is I think the easiest among those scale. There are instances wherein comparison is necessary and cannot be avoided. So, but the rank data or the ordinal data generated is limited also to the extent of greater or less than. It is not capable of telling information about how much greater or how much less. So this ordinal data concerns with rank data, or it provides the ranking of observation in order to generate information to the extent of greater than or less than. So ordinal scale can be illustrated in sports activities like marathon or in a fun run. Finding the order finish among the participants in a fun run always come up with a ranking. So, however, ranked data cannot provide information as the difference in time between first placer and second placer, right? So we have first placer, second placer, third placer, and relative to this, readings reports with ordinal information is also tricky. Next, interval scale. It deals with the measurement data in interval scale, we assign numbers in such a way that there is a meaning and a weight on the value of points between intervals. So this scale of measurement provides more information about the data. As you can see in the nominal scale or nominal data, we use numbers to label categories. Like in marital status, we use number 1 for single and number 2 for married. While in the ordinal scale, we use numbers to merely provide information regarding the greater or less than. And let us take a look what is the example of this interval scale, so that you can be able to differentiate interval from nominal and ordinal. Say here. Consider the comparative illustration below. We have academic performance of 5 students in a certain class. So as you may notice, the interval scale provides substantial information about the grades of students. Student A earned a grade of 99, so on and so forth. Now look at the information given by the ordinal data. It is simply about ranking. With this information, student B can proudly and rightfully claim the second place in the ranking. Ordinal scale is a trusted friend to keep a secret that the grade of student B, though claiming second place, is actually 74. Let us analyze the nominal data in our example. So, yun nga, hindi naman ibig sabihin na you are one of the top ay magaling ka na. Because as you can see from the ordinal data, the student B placed as, position in a second placer. But, specifically, he gained or she gained a 74 mark. And then in the nominal data, we are going to represent it or interpret it. So with this scale, it is also alright for the school, sadly, to announce that only one student passed and 4 students failed. Nominal data cannot provide more information, specifically provide brighter limelight to student A. So audience may assume that student A just got passing grade a little bit higher than the passing mark, but student A grade of 99 will remain hidden forever. So it's tricky as well. Nominal data is tricky as well, even though it provides interpretation. Because say, for example, you have the passing mark of 75%. And yes, for nominal data, you are being marked and known as pass. So since other people know that you pass, then you will be known as you have the probability that you are only 75 or 76, like that. So it is not known. But with the use of our interval data, we can be able to identify the specific scale of each of the students. So it is already included that student A got 99, right? And then we're going to move forward to the next kind of scale. We talk about 3 already. The nominal, or if you would like to get an idea how you're going to remember this nominal already, it is like somewhat like quantity, specific quantity you're counting. Ordinal is like your ranking. And then on the third one, interval, that is the measurement. You're interpreting the data. So nominal is just like categorical data. And now, here we have ratio scale, the fourth type of scales of measurement. This is an extension of an interval scale. It also pertains with measurement data, but ratio's point of view is about absolute value. Because of this, we oftentimes cannot utilize ratio scale in the social sciences. So sometimes sometimes there are specific fields in our industry that they are not using the ratio scale. So we cannot justify an absolute value to gauge intelligence. We cannot say that our student A with a grade of 99 has an intelligence several points superior than student E, who hardly but successfully achieved a grade of 70. Right? Okay. So again, those 4 types of scales of measurement: nominal data, which is categorical, or ordinal data, which is somewhat like ranking, or you're getting the position, and interval data, measurement of data, that is you are interpreting. And then the ratio scale is also one of the measurement of data that is being not sometimes used, right? It is being sometimes used on some of the field of industry. Okay, and this ratio scale is already an extension of an interval scale. Now, we have different key concepts in statistics. Of course, you need to remember and understand what is the population. A population can be defined as an entire group of people, things, or events having at least one trait in common, according to Sprinthal 1994. A common trait is the binding factor in order to group a cluster and call it as a population. So merely having a clustering of people, things, or event cannot be considered as a population. At least one common trait must be established to make a population. There should be one common trait. But on the other hand, adding too many common traits can also limit the size of the population. So what do I mean by that? Let us take a look with this example. In the illustration below, notice how a trait can severely reduce the size of membership in the population. So it started from this top one, a group of students. So this is a population since the common trait is students. So we can consider it as a population. And we can reduce it. Just like this on our second population statement, a group of male students. So we have another category which is male students. And then we make it as a group of male students attending the statistics class. So we add another category who are attending statistics class. And then the fourth one, a group of male students attending the statistics class with iPhone. So there's another category. Of course, you can be, it's free for you to add categories on the population itself. And specifically, we'll make it reduce again. A group of male students attending the statistics class with iPhone and earphone. Okay, so it's very important that you know how to categorize data, right? So that you can be able to represent well your population. And also we can also encounter this word parameter. In gauging the entire population, any measure obtained is called a parameter. Situationally, if someone asks you to what is the parameter of the study, then bear in mind that he is referring to the size of the entire population. Okay? If it's parameter, bear in mind that he is referring to the entire size of population. In some situations where the actual size of the population is difficult to obtain, the parameters are in the form of estimate or inference only. Okay? Parameter, remember, parameter is referring to the size of the entire population. So let's make it smaller. That will be the so-called sample. Sample, the small number of observations taken from the total number making up a population, is called a sample. So as long as the observation or data is not the totality of the entire population, then it will always be considered as a sample. Say for example, in a population of 100, then 1 is considered as a sample already. 30 is clearly a sample. It may seem absurd, but 99 taken from 100 is still considered a sample. But once we say that we have 100, that's not a sample because it's already the totality of the population. So not until we include mathematics in the modern world, like mathematics in the modern world 102, the last number making it 100, would claim it as already a population and no longer a sample. As I mentioned, if you make it as 100 already, then it is a totality, then we cannot call it as a sample. It should be a part of the totality of the population only. So that's we can identify it as a sample. Now we have statistic. In gauging the sample, any measure obtained from the sample is called statistic. So sample, we obtain it from the population. And parameter is the entire size of the population. Okay, I make sure remember the sample came from the population because we get the part of it. Okay, and also now we have statistic. We obtained the obtaining from the sample is called statistic. Whenever we describe the sample, then it is called statistics. Since a sample is easier to observe or gather than population, then statistics are simpler to gather than the parameter. Say it is just like the equivalent of a parameter. Parameter to population, then we have statistic to sample. Then we have different graphs. It is another way to visually show the behavior of data. To create a graph, distribution of scores must be organized. Say we have this kind of data. So presenting the scores in an unorganized manner can provide confusion or no information at all, just like what you are seeing here in this inside the box. We are just seeing numbers. So what are these numbers referring to? Right? This is not well organized. So for instance, in all the scores provided, presenting the scores in not well organized manner, it give us the confusion what it is referring to. So how are we going to represent this kind of data? When we arrange the scores from lowest to or highest to lowest, which is a form of score distribution, some pieces of information can gradually brought forth and exposed. Say, we titled as distribution of scores, and we arrange it from highest to lowest, and it's somewhat like organized, but let us make it more organized. This still can be organized in a form of frequency distribution. So the score distribution can still be organized in a form of this, the frequency distribution. And frequency distribution provides information about the raw scores. So how many got 120, how many got 110, like that. And the frequency of occurrences. Frequency distribution provides clearer insights about the behavior of scores. And let us make it more simpler again. Let us take it away or organize it into a tabular form. A tabular form has the advantage of showing the visual representation of the data. And another alternative way of presenting data in frequency distribution. So from the frequency distribution, you can be able to provide a tabular form data. A tabular form has the advantage of showing the visual representation of the data, and this kind of presentation is more appealing to the general audience. Kesa naman dun sa pinakaunang data natin na nasa inside the box, it is spread and not organized. So in this kind of form or tabular form, you can be able to determine what happened to those presented data. And in the last part, another way of showing the data in graphical form is by using the Microsoft Excel, as also illustrated in the graphs here. It is the frequency polygon of the scores in our cited example above. Notice in the illustration of the frequency polygon here, the two graphs may appear different, but they are actually the same, and they disclose the similar information. This illustration allows you to realize that unless you see things with a critical eye, a graph can create a false impression of what the data really reveal. So this is an obvious situation showing how graphs can be used to distort reality. So if you're not equipped with the critical statistical mind, this type of deceitful cleverness in distorting graphs is common to some corporations, devising the tinsel to camouflage and also to portray some gigantic leaps in sales in order to attract more clients or buyers. So from the data that I presented to you a while ago, those numbers inside the box, and then we got the highest numbers to the lowest. We started from that, and then we make it as a frequency distribution. And from frequency distribution, you can be able to create a tabular form data. And from the tabular form data, you can use a Microsoft Excel to graph it. And we have different kind of graph, like circle graph, line graph, bar graph, and anything else. I know that you are already aware of that. Okay, and now that will be all for today. So I hope